Shut up and sit down.
Well, hey everybody, welcome to another episode of Master the NEC, where we talk about the National Electrical Code and all things electrically related. Welcome all my code junkies. My name is Paul Abernathy, your host as always, and I want to thank you for taking the time out of your day to listen to this podcast. And I also want to thank you for all of the love we've been getting lately from everybody that's been passing their exams and using our Fast Tracks program. And we're really encouraged when we hear that because we spent a lot of time developing the program. I spent a lot of time working with students and working out Wednesday night and doing training with students and answering emails. And I really do like it when I see you succeed. It really means a lot to me to see you be successful, and I want you to be successful. That's the whole reason that I put the program together. That's the whole reason that I selected the partners that I have in this program to allow me to bring this content, the LMS backbone system. Really excited about it. And again, 2021 is setting up to be an amazing year for the Fast Tracks program and all my students. So if you know anybody who's really trying to learn the NEC, whether it's for an inspector exam, electrician's exam, whatever, if they need to learn the National Electrical Code, this is a program. I don't believe in sitting somebody in front of a TV and watching tons of videos. I believe you need to read the content. And if you can read it and you still don't do well on a competency test, it means that you have a problem with what's called reading comprehension. And reading comprehension is nothing to be ashamed of. Sometimes when you're reading technical material, you can read a sentence, and after you finish that sentence, you're thinking, what the heck did I just read? You're not alone. That happens to a lot of people. So don't get discouraged. You're going to get it. I recommend that you get into a structured program like our Fast Tracks program. And really, if again, you can spend an awful lot of money, and sometimes we don't equate time with money. There's people that have been studying for a year, and through our program, they could have been ready in 60 days or 90 days if they follow our study plan. So again, all about your time. It's all about what's precious to you. I think we have the lowest cost in the industry for what you get. I mean, you're getting directly with me every week, 2 hours every week. You're getting access to an expert to ask questions, send feedback. I grade every one of the competency reviews personally on all of our students. We have well over 1,000 in the program. I physically sit down and grade their work. And look, I give feedback. I'm not sure where else you could get that in a NEC learning program, but we do it here at Electrical Code Academy Incorporated. So check that out over at our website, masterthenec.com. Go check it out. All right, so today's episode, we're going to talk a little bit about supply-side bonding jumpers and how to size them. That's what we're going to focus on today's podcast, how we size supply-side bonding jumpers. Now, supply-side bonding jumpers can either be on the line side of a service equipment, but also it can be from the secondary point on a transformer to the first overcurrent protector device of the system that's derived from the secondary of that transformer. And so you'll have to size what's called supply-side bonding jumpers. However, for today's episode, even though it's pretty germane to both situations, how you would do it, we're going to be dealing with service side, so line side of a service application for our episode so that we can kind of keep it easy for you to understand. Because, I know it's a podcast, and I know that I have a tendency to talk very quickly. So I want to make sure that we cover it all and that you fully understand the sizing. I'll also remind you that we are going to go into this really deep in our February mini webinar, and that is February 20th at 2 p.m. Central Standard Time. If you want to find out more on that and you'd like to get involved in that, seating is limited, then you need to go to www.electricalinstructor.com. That's electricalinstructor.com, and at the bottom, you'll see where you can sign up for that if you're interested in taking part in that mini webinar. We're going to have quite a few mini webinars this year on different topics. Okay, so it should be pretty interesting. All right, so let's talk about it. So let's talk about sizing a supply-side bonding jumper. First of all, let's kind of draw a picture of what we're working with here. Let's say I have a piece of service equipment, and I'm going to be coming in, and then I'm bringing in my service entrance conductors on the supply side or the line side. And I'm coming to this enclosure. So now these conductors, for our example today, these service entrance conductors really don't have any protection on them. Now, once they go through the overcurrent device, the service disconnect, then they're going to have some protection on there, right? They're going to have some overload protection, but that's about it. They're not going to have anything else. They're not going to have short circuit or ground fault protection. But we understand the National Electrical Code says, look, you're going to need to bond those raceways so they're at the same potential as everything else. As an electrician, I'm not concerned with what's upstream. I'm not concerned with what the utility might have, some type of fuse on the primary side, and I can't control that. I can only control what the National Electrical Code says. And again, many people know I'm not going to waste your time in trying to get into theory because the code says what it says. Now, if you want to know the theory, we have a theory course, but we are examining the National Electrical Code. So what does the code tell us we have to do? Okay. So when we're going to bond those raceways, and remember, since these are service conductors, you have to also follow the rules in 250.92, which is kind of an over and above assured level of bonding that has to take place. And so I'm going to give you some givens today so that we know what we're working with. So I've got a service disconnection means inside of a cabinet. So this is service entrance equipment, and it's coming in with a raceway into the top. Okay. So now I'm not coming through a Myers hub. I'm not coming through a hub. Let's just say it's for ease of understanding, it's coming into the top. So I have a metal raceway coming into the top of my enclosure, and assuming everything else is okay, now we have a raceway and we're going to have to bond it. Okay, now let's assume that we're coming in, well, not even going over the top, because you got those people out there who say, oh yeah, Paul, but it's got to be a Myers hub. Okay. So we're going to come in from the side. How about that? We're going to come in from the side, and we're coming through a concentric or eccentric knockout. So now we're going to have to, based on 250.92, we're going to have a bonding jumper. So this would be a supply side bonding jumper because it is containing conductors that are on the supply side of the service disconnecting means. So how do we size it? Well, in our case, let's say it was just right now, let's just kind of paint these different scenarios. Right now, it's just one raceway. And in those raceways, I have 500 kc mil. Okay? So I have let's say it's three phase. So I've got black, red, blue, and a neutral. And they're 500 kc mil ungrounded conductors. Neutral size doesn't matter in this situation for what we're doing. So I've got these ungrounded conductors. Phase A is 500 kc mil. Phase B is 500 kc mil. Phase C is 500 kc mil. Now, I want to bond this raceway as it connects to the enclosure because it's connecting to an impaired knockout, a concentric or eccentric. You have to go look at 250.92, but just take my word for it. It requires a bonding jumper. So what we're doing is we're going to be doing a supply side bonding jumper sizing. Well, if you go to 250.102C1, this is the perfect scenario because we have only one raceway. And I've got 4 conductors within that raceway. Again, it's a service side. Okay, no equipment ground involved here, just the hots and a neutral. So it says size, C1 now says size of supply conductors in a single raceway or cable. It says the supply side bonding jumper shall not be smaller than specified in table 250.102C1. Well, this is pretty simple, right? So if you look at this table, it's right there next to it. You'll notice that it's broken down into 4 columns. The 2 columns on the left deal with whether it's copper or aluminum or copper-clad aluminum ungrounded conductors. And on the right is the sizing of grounded conductors as well as the various bonding jumpers. And you notice there's an asterisk there. If you follow that asterisk and you go to the very bottom after all the notes, you'll see that that asterisk says, for the purpose of this applying this table and the notes, it says the term bonding jumper refers to main bonding jumpers, system bonding jumpers, and supply side bonding jumpers. Okay, so if you didn't know what that asterisk was sending you to, that's the little note, little asterisk at the very bottom of all the notes that go with table 250.102C1. another thing I'll tell you is all these notes, they're very much applicable. These are not informational notes. They very much go with the table, so they will give you direction, and we'll kind of talk about them briefly, but they will give you direction. Now, I will go in much more detail in our webinar on February 20th, so we're going to keep it very light today, but I think you'll get the gist of all the information. Okay, so that was pretty simple. So I'm coming in with this raceway into the side. I need a bonding jumper. I'm going to put a bonding bushing on it with a lug. And now I need to take a supply side bonding jumper from that lug over to my grounded terminal bus, which should have a main bonding jumper in it that connects it to the metal enclosure. Okay, should all be there. In this case, let's say that one is a green screw and there's no sizing involved in that. It's already done for us from the manufacturer. So that part's done. So I've got to put in the supply side bonding jumper. So how do I size it? Well, since we're going to assume copper always, unless stated otherwise, we're going to go to table 25102C1. We're going to go down the left column, which says copper, and we need to know what was the size of our ungrounded conductors. Well, it was 500 kc mil. Remember, it's A, B, and a C in a neutral, and A, B, and C all were size 500 kc mil. Okay. So I go down this list, and I notice that my 500 kc mil, you only have to take one phase now. You don't add up A, B, and C and do this. You just take one phase. It says over 350 through 600. Well, our 500 falls right in line here. Then you follow that to the right. And if your supply side bonding jumper is copper, then it's going to be a 1/0. If it was aluminum, it's going to be a 3/0. Okay? Pretty simple, right? So that's all you would do. Now, let's make sure we cover all scenarios because I don't want to leave any stone unturned. What if we did the same application and it was only one raceway, but instead it was two sets of conductors in there? So we had two A's, two B's, two C's, and a neutral, property size neutral. Okay? So what if that was the scenario that we were dealing with? Okay? All right. How would we deal with that? Well, it's still one raceway. But if you go look at this table again, notice in the columns that are on the left, and if you're looking at table 25102C1, notice up the language up at the top, just underneath the bold line. It says size of largest ungrounded conductors, or. Okay, or is a powerful word in the NEC. The or and the and. So this says or equivalent area for parallel conductors. Okay, so what do we talk about? So if I have a single raceway and I have two A's, two B's, two C's, and we'll only deal with the ungrounded hots here, then what's considered equivalent area for parallels means that you're taking any one set or any one phase, I should say. So let's take A. Let's always work with A. Keep it simple, right? If they're all 500 kc mils, then it doesn't matter, right? So if any one of those phases sets were larger than 500, and a weird, odd chance that ever happened, then you go with whatever the largest would be, whatever the largest phase set would be equivalent, okay? But in this case, the A's, the B's, and C, they're all the same size, 500 kc mil. Okay, and that's the way you're usually going to get it. So in this case, since our single raceway had, basically it had two A's that were 500 each, two B's that were 500 each, two C's that were 500 each, and your neutrals. Okay, how do we size that? Well, it says equivalent area. So you simply take the A's and you add the two together. There's two of them in there, two sets in one raceway. Again, remembering the raceway's got to be sized properly and everything's, in accordance. Let's assume it all is. And your raceway's large enough. If that was the case, then what we would have was 500 and 500. It'd be 1,000 kc mil. So then I go back to this list because that would be what's called the equivalent area of those parallels. And you come down, and that would be over 600 through 1,100. Then you go to the right, and that would be 2/0 copper, okay? Or it could be a 4/0 aluminum. Now, that's going to be the size of your supply-side bonding jumper. From that raceway's lug on that fitting, on that bushing that's on that raceway, from there over to your grounded terminal neutral bus, okay? And that's how you size. So that is your supply-side bonding jumper, whether there's one set in there or multiple sets in the single raceway. That's how you would size it, Pretty simple so far, right? Let's move on to what happens when you have 2 or more raceways. So maybe we don't want to put all of them because nobody wants to run a trade size 6, a big old hawking raceway. But it's much easier, let's say, for them to run 2 separate raceways. Okay, so let's assume that we're taking what we just used as our example. Same scenario, coming in the side of the equipment, service entrance equipment, right into the cabinet. Obviously, we're going to need jumpers because they're concentric or eccentric knockouts, so it's an impairment. So we're going to have bonding jumpers involved. If you read 250-92, you'll know that. So in this case, how do I size it? So this moves us to C2. Now, C2 has 2 options, and we need to read it so we can fully understand what these options are. And basically, it allows you to either run individual supply side bonding jumpers, just like what we did for that single raceway, or we can run what's called a single supply, not an individual, but a single supply side. And basically it daisy chains and loops all the raceways. Okay. Goes to the first one and continues on to the second one. So I can run individuals to each raceway, or I can run one of them and have it loop through lugs on each raceway. Okay. So how do I do that? Well, let's deal with the first one here. It says, and I'm at 250-102 C2 now. It says size for parallel conductors or conductor installations in 2 or more raceways or cables. It says where the ungrounded conductors, supply conductors, are paralleled in 2 or more raceways or cables, and an individual supply side bonding jumper is used for bonding these raceways or cables. The size of the supply side bonding jumper for each raceway or cable shall be selected from table 250-102 C1 based on the size of the ungrounded supply conductors in each raceway or cable. Okay? So doesn't that sound exactly like C1? If you want to do this option, then I can take each raceway by itself. So in our example, we split it up, and now we have 2 raceways with 500 kc mil, ABC, and a neutral in one, and then ABC and a neutral in the other. All the ungrounded conductors are 500 kc mil, but in this case, I get to treat each one of those raceways separately, and I size that supply side bonding jumper separately. So first raceway, phase A, remember, just use one phase. That's 500 kc mil. Okay, so go over to this table. 500 kc mil says over 350 through 600. You go to the right for copper, if that's what your supply side bonding jumper is going to be. And that would be a 1/0 copper. And so I go from that raceway's lug on that fitting over to the grounded neutral bus. And it could be bare, it could be insulated, does not have to be green, it could be black, you can put green tape on it, whatever you want. But that's how you size that single supply side bonding jumper for that one raceway, that individual supply side bonding jumper, I should say. Now, you would do that for both raceways. Each one would have their own. Okay, that's what it means when it says that you can run, when it tells you in there that you can run an individual supply side bonding jumper. Now, what if I want to run a single supply side bonding jumper? Means I don't want to run one separate to each raceway. I just want to run one and go to the first one and then loop through the lug and go on to the next raceway. So that's the last sentence in C2. So let's look at this option. It says, a single supply side bonding jumper installed for bonding 2 or more raceways shall be sized in accordance with 250-102 C1. So in this case, we're basically treating these 2 raceways as if it was a single raceway like we did in C1, and we have to add phase A in one raceway with its comparable phase A in the other raceway, okay? Because they're the ones that are in parallel. They're just in different raceways. So just like we did with C1, you just simply take the 500 in the first raceway for phase A, and you add it with 500 in the second raceway for that phase A, and that's 1,000 kc mil. So if that's what I want to do, then I go back. That's now what I consider my equivalent area for those parallel conductors, because those phase A's are in parallel. I go back here and I go down the copper list if it's copper, and I notice that it says over 600 through 1,100. Well, that 1,000 kc mil equivalent falls right there. And then I go to the right, and that's a 2/0. So I could get away with a 1/0 to each raceway, or I could get away with a 2-aught, and I could daisy chain both raceways to a single supply side bonding jumper. Now, when you only got 2 raceways like that, it's very small. There's not a whole lot of difference, obviously, between 1-aught and 2-aught. And maybe you have that on site, and that is, easy to obtain. The problem where this can happen is when you start getting upwards of 4 raceways in parallel or 5 raceways in parallel, then it's a problem, because when you start adding up those 500 kc mills, let's say it's 4 raceways, for example, and I'm going to run one single option for my supply side bonding jumper. I just want to run it from the bus, a neutral bus, a grounded terminal bus, over and loop it through a lay-in lug at each raceway, on each bushing. And you're thinking, okay, well, that's simple. Well, here's where it becomes a problem, because you have to add phase A from each one of those raceways. Okay. And again, you could use phase B or phase C. If they're all the same size, it doesn't matter. If you happen to have one size that's larger than the others, then you're going to obviously use the largest in this equation. But in our case, all of them are 500 kc mills. So I'm going to go 500 times 4. So 500,000 is what we're dealing with, kc mil, times 4 equals 2 million or 2,000 kc mil, or 2 million circular mil. Okay, so this is when you get into the situation where you have to go now down to the notes. So now we're going to look in this situation where you look at note 1. Now, note 1 says, if the ungrounded supply conductors are larger than 1,100 kc mil copper, and equivalently they are, we just said they're 2,000 kc mil, so obviously this note 1 is going to apply. And then, of course, 1750 aluminum, it says, the grounded conductor, or in our case, the bonding jumper, shall have an area not less than 12.5% of the area of the largest ungrounded supply conductors, or equivalent area for parallel supply conductors. And that's what we did to get our 2 million circular mils, or for easy understanding, 2,000 kc mil. So that's what we did. So the code says that I have to take that at 12.5%. So 2 million times 0.125 equals 250,000. So what size, if I want to run a single, if I want to run a single supply side bonding jumper, I only want to run one wire from the grounded terminal bus through each one of these lugs on these raceways at these fittings, I would have to run a 250 kc mil. Now, what problem can happen is that lugs go up to a certain size, and then you have to get lugs that can handle the size we're dealing with, which would be a 250 kc mil. Obviously, it's not going to be a problem if I were to run an individual to each one of those raceways, because they only had 500 kc mil in it, then I would only need a 1-aught to each one. But in this case, if I wanted to run one and loop it through it, it would have to be 250 kc mil. You got to be careful, because your lug might not be able to receive a conductor that size. And you might end up spending a lot more money trying to find a lug that can receive that size of conductor than it would be just to use a more readily available lug and just run individual 1-aughts to each one of those raceways and be done with it. But you have to think about how you're going to approach this. And you do have options, but that's what C2 is giving you. It's saying, I'll let you run a single to each raceway, or I'll let you run an individual supply side bonding jumper to each raceway, or I'll let you run a single supply side bonding jumper, and I'll let you loop it through all of the lugs at each one of these raceways if that's what you want to do. But it's going to result in a bigger conductor. It just is. Okay. So that's kind of what note 1's kind of telling you. Now, note 2 is just saying, look, if I've got ungrounded conductors, and once I'm over 1,100 kc mil, this only comes into play because when it's less than 1,100 kc mil copper or less than 1750 aluminum, then pulling from the table is going to be okay. For example, if I have copper conductors, it tells me if I'm going to use a bonding jumper that's aluminum, you can pick it from the chart and you're fine. Once you get over that size, it can be a little more difficult, because what this is saying is if you pick a copper conductors as your supply conductors, but your bonding jumper is aluminum, you have to make sure that the aluminum bonding jumper is sized equivalent to whatever the size would be for the ampacity of the copper conductors, and vice versa. Okay, so it's making sure that you don't just pick the same size copper in the same equivalent size in like a I don't know, for 500 copper that you pick 500 aluminum. You don't want to do that. You want to make sure that your bonding jumper, if that's aluminum, can handle the same amount of current as being considered for your supply conductors. Okay, so it's reminding you of that. This only kicks in when you're over 1100 kc mil copper or 1750 aluminum. That's when Note 2 is going to kick in. And Note 2 says, and I'll read it so that we have a good understanding of it. It says, if the ungrounded supply conductors are larger than 1100 kc mil or 1750, that's copper, or 1750 kc mil aluminum, and if the ungrounded supply conductors and the bonding jumpers are of different materials, like copper aluminum or copper clad aluminum, it says the minimum size of the grounded conductor, or in our case, the bonding jumper, shall be based on the assumed use of ungrounded conductors of the same material as the grounded conductor or bonding jumper, and will have the ampacity equivalent to that of the installed ungrounded supply conductors. Okay, so again, making sure that your conductor, your bonding jumpers are size adequate based on whatever the size you're using for your ungrounded supply conductors, so that that works together, is important. Now, I don't know that we come into that very often, and in my webinar, I'll give an example of this, but usually if there's copper conductors coming in, that we're going to use copper conductors for the supply side bonding jumper, okay? And really, to make it clear, what it's saying is if you actually look at the table and let's just take the over 600 through 1100, for example. You'll notice that over 600 through 1100 in table 250.102C1, the copper size jumper would be a 2-aught, whereas the aluminum would be a 4-aught. Why? Kind of same thing at note 2 is what it's saying, is that you just need to make sure that the aluminum bonding jumper can handle the same equivalent it would be if it was a copper bonding jumper. So it's got to have the same current carrying ability. All right. And again, we know that copper and aluminum don't carry the same amount of current. We usually have to increase the size for aluminum to carry the same amount of current as copper. So that's all it's reminding you to do. Okay. So if I have copper conductors coming in and I've got an aluminum bonding jumper, it's reminding me to make sure that aluminum bonding jumper is sized adequately to be able to handle the current equivalent to what it would be if it was copper. Okay. All right. So that's what you get for 2, and we'll go over that a lot deeper in the webinar. Note 3 and note 4. Note 3 is just reminding you that when you have the allowance in 230.40, that's where you can have multiple service entrance conductor sets going out to different occupancies and things like that, that you're only sizing it based on that set. Okay. And same thing, it has an exception here for when you have, let's say, a separately derived system, and it comes from a transformer and then goes out to different, up to 6 different locations for disconnects, that you're sizing based on each individual raceway. Okay. Each individual one. Okay. And then of course, 4 is saying, you'll have some occasions where you don't have service entrance conductors, that you've got service entrance underground, and that came from a utility. So they're coming up and into something, and you might be going, well, I don't size those. How do I size a supply side bonding jumper here to bond those raceways? Maybe it's coming in through an open bottom switch gear, or something's coming in, and it's supplied by the utility. Since they're not service entrance conductors, they might be service entrance underground conductors. You have to do a calculation, and you have to know what the load is to be served, and you have to size your conductors as if you were sizing them. Even though you're not, there's service entrance underground conductors coming in, maybe by the utility, but you have to come up with what you would size if you were sizing the conductors for your load to be served. Okay, you got to do a calculation, just like you normally would, and let's just pretend that you're the one that's going to have to pick these conductors. That's what it's saying do. And once you determine what conductors you would use, then those are the values you use when you go to table 250.102C1. And that's how you would do it. So again, that's something that you have to calculate out, and you have to determine what size they would be to handle the load that you calculated out. And then those conductors, and they might not necessarily be the size that's being run to the service by the utility, but since they're not service entrance conductors, you have to come up with the sizes that you would need to use if you were sizing them. And then you use those sizes, and then you go to table 250-102C1 and you apply the rules here. Again, if it's over 1100 kc mil copper or 1750 aluminum, then a 12.5% is going to kick in. Okay, so that's what the different notes are about. Obviously, we'll talk about that in more detail in the webinar. Hopefully, you can check out that webinar on February 20th at 2 p.m. If you have interest in that, go to our website. That's www.electricalinstructor.com. electricalinstructor.com, and scroll to the bottom. You'll see where you can sign up for that webinar. Limited spacing for that, but hopefully you'll be able to join us. Well, that's it. Kind of a brief overview. Tried to do it in about 30 minutes. Hopefully you got something out of it. Until next time, folks, stay safe. God bless.
Shut up and sit down.